Okay, guys, quick review of arc length, and we're going to dive into the idea of area of a sector as well. We hadn't got into it. They both are related to each other. Area of a sector is obviously area of a portion of a circle. The length of these arcs on the outside is actually just a portion of the circumference. Okay, and then we're going to talk about how to use these two formulas to help us solve some of these more difficult ones where we're looking for radius and circumference different than actually just plugging in and finding those answers. So quick review of the actual formulas. So arc length formula is right here. Area of a sector is right here. So this says that arc length is the central angle divided by 360, which makes sense because this right here tells us the arc portion of the circle. That's what this calculation here tells us. This one is the circumference of a circle. If we take the whole distance around and multiply it by the portion that we want, guys, we're going to get the amount of the circumference that we have. Same thing happens down here, except this thing changes to the area of a circle right here. So let's go ahead and actually answer these first two problems. So I put these two formulas right here. So arc length, so length RS, and we're always going to assume the minor arc here, the smaller one. So length of RS is this. Our central angle, our theta in this thing, that's this. And here's our R. So when we're finding the arc, it's going to be 60 divided by 360 as both degrees. And we're going to multiply that thing by 2 pi times the radius, which is 8 centimeters. So let's go through and let's actually plug this in. So 60 divided by 360 is 1/6. And if you actually do this, you can leave pi alone when you go through this. This is 16 pi. And I'm going to exclude the centimeters down here. It's just along for the ride for the answer. Those are the two things that we want to multiply together. So 1 divided by 6, hit enter, times 16 second, and the second power button on your calculator to give you the pi symbol. I get 8.38. I'm going to round to two places. And those are measured in centimeters. So our arc length is right there. Now we're going to do area. And I'm going to do this at the same time because I'm using the same central angle here. So this is going to be 60 over 360. And I know that's 1/6. I want 1/6 of the area this time, though. And the area of this, on the area of a circle with pi r squared. So it's pi 8 centimeters squared. So we're going to get 1/6 of 64 pi centimeters squared will be with our answer. So we got to go 1/6 again, and hit enter. Then we're going to multiply that by 64 pi. I get 33.51. And those are centimeters squared because area is measured in square units. We're going to repeat this process for the second one. This is our theta. There's our R. We want the length of the minor arc right here, which is MN. So we're going to do this the same way. So the arc is going to be 120 over 360, and we're going to go 2 pi r because we want the arc length. And here we're measured in centimeters again. So this is going to be 1/3, 12 pi. So we go ahead and plug all that in, and we get 12.57. And we're measured in centimeters because this is just a length. It's 12.57 centimeters. Let's do area. And with area, it's the same central angle. We're finding the area of the same piece. So this is our 120 over 360 but this time it's going to be pi r squared, so it's pi 6 centimeters squared. So we get 1/3. 6 squared is 36. So this is going to be 36 pi centimeters squared. So 1/3 of 36 is 12, and we're going to multiply that by pi. So 37.70 is what I got. And it's measured in centimeters squared. So it's the direct calculations. Plug in your radius, plug in your central angle. Gonna have to use a calculator for this one. Just be careful. All right, so we're gonna do this one. We want to find the radius given the information here. So let's go ahead and figure out what we're actually given here. So this 1.57 feet, this is the arc length. This 45 degrees, this is our theta, and it's asking us for the radius. The radius would be right here. So if we actually look, we have the arc length formula. We have arc equals theta over 360 times 2 pi r. And the r is what we are searching for. We know the theta is 45. We know the arc length is 1.57. We know this is 45 degrees. So let's figure out what 45 divided by 360 is. So 45 divided by 360 gives us 0.125. We can use that. So what happens is, this is 0.125. We're going to divide that to the other side. And then to get rid of this, what do we have to do? We've got to divide that as well, don't we? So we're going to take this answer, 1.57.125, and then we're going to divide that thing by 2 pi when we're all done. That'll tell us what the radius is. So let's go ahead and do that calculation. So 1.57 divided by 0.125, 12.56, and I'm going to divide everything by 2 pi, and I get 1.99898, and I'm going to round that up. That's going to be 2. So that means the radius is 2, and I'll even put 2.0 because showed that I had some accuracy there. It's all 9s and 8s. So sometimes you'll be asked to solve for different parts of the formula given all the other parts. You'd be given the arc length and asked to find something else in the formula. That's what happens here. We want to find the circumference with this thing. So nothing with area. We're going to do with arc length again, because this number right here again is the length of that arc. So we're dealing with arc length again. So the arc is theta. Let me try that again. Ooh. Theta over 360 times 2 pi r. Notice we're not given the r, but they want the circumference. The circumference is 2 pi r. So another way to write this formula is the arc length, our theta angle divided by 360 degrees times the circumference. This is what we actually want to solve for in this problem. We want to find the circumference. So we just need to plug in the arc length out here, the angle, and then divide those results, meaning this is 41.87, and it's centimeters. And this was 200 degrees divided by 360. And that multiplied will give you our circumference will give us that. And that's what we want to solve for. So 200 divided by 360 is 0.555 forever. Let's go ahead and make that a fraction. That's 5/9. So we need to take this 41.87 when you divide it by 5/9. Put that in parentheses when you plug it in. And that will tell us the circumference of this circle. So 41.87 divided by 5/9 is 75.36. So the circumference of this circle is 75.3, let's do 37 and round it. And our centimeters right here, so that means our answer is in centimeters. And there it is. Make sure you message me if you need help, guys. I'll be here all week.